In many cases when discussing chemical reactions, it is convenient to describe the processes involving reactants combining completely to form new product or products. In reality, many reactions do not go to completion, but stop when there is a stable mixture of reactants and products. These reactions reach a point where a small amount of the product breaks down into reactants, while at the same time, some of the reactants combine back into the products. To indicate this back and forth between products and reactants, the equation is drawn with a bidirectional arrow showing that at equilibrium, the reaction is occurring in both directions. The concentration at which the reaction is going forward and backward at the same rate is called chemical equilibrium. And the concentration of the products and reactants at equilibrium depends upon a number of things, including how energetically favorable the electron arrangements are in each compound. If we start with just a mixture of a set of reactants, the forward reaction will begin to form product. Since there are no products, the reverse reaction will be negligible. As the reaction proceeds and more products are formed, the rate of the forward reaction will slow down and the reverse reaction will begin to form small amounts of reactants from the products. The rates will still be imbalanced so that over time more products will be formed until the system reaches a point where the forward and reverse reactions are occurring at the same rate. This is equilibrium. Both the forward and the reverse reactions are occurring, but on average, the concentration of the compounds in the mixture does not change. Reaching equilibrium does not mean everything is present in equal combinations. If the energetics of the reaction favors the products, the equilibrium may occur at a point where there is very low concentration of reactants mixed in with much larger concentration of products. The final mixture contains reactants, but the reactants are present at very low concentrations. While the equilibrium concentration is controlled to a large extent by the energetics of the reaction, other factors do play a role. One way to alter the equilibrium is to add more of one of the compounds involved. For example, increasing the concentration of the product will push the reaction towards the reactants. In more complex mixtures, reactions are often linked, and the products of one reaction may be the reactants in another chemical reaction. As the products of the first reaction participate in the second reaction, the concentration of these products drops, pushing the first reaction towards the formation of more products.